Hello everybody and welcome to this presentation hosted by WeID by BeFree Solutions at our RFID Journal Virtual Live 2020. With us now is Alessio Cucini, who is the Managing Director of BlueUp Italy, co-founder and one of the pioneers of the beacon industry in the world. Thank you very much, Alessio, for being with us today, and we will be very happy to listen to your presentation. Go ahead.
Okay, thank you, Luis, for the invitation and for this occasion for the RFID Journal Virtual Live. So in this presentation, I will go to make some insight on beacons, Bluetooth Low Energy beacons fundamentals. So it will be a sort of overview of BLE beacons from the very beginning to the industry application. So just a brief introduction about myself, or more correct about BlueUp company. Was founded in 2014, and BlueUp was one of the first company worldwide to work in the Bluetooth Low Energy beacons market. And we have an internal team for the design of our devices from the firmware to the hardware. Our products, I will see later, are certified for the main BLE standards, and we also provide solutions for real-time locating systems and for indoor positioning systems. This is an overview of the contents of this presentation. I will show some basics about beacons, about Bluetooth Low Energy and the standards for Bluetooth beacons, and I will make some, will spend a few words about new solution from Bluetooth 5, mainly angle of arrival, angle of departure, and mesh network. And then I will provide some insight about our technology portfolio and product, and with some focus on industrial application. So let's start from the very beginning. So what is a radio beacon? A radio beacon is essentially a wireless transmitter, a radio transmitter that periodically transmits its some limited information. Typically its own identifier or some kind of other information like telemetry. So radio beacon is a terminology which is in the engineering area from maybe 100 years. So it was reused from a few years, and we will see why. So sometimes you will hear about beacons, sometimes you will hear about tags. So which is the difference? So essentially there is no difference from the hardware and from functionality, because tags and beacons are wireless transmitters that periodically advertise their unique identifier. So the difference is mainly comes from the market. So the term beacon is mostly used in the mobile industry, and most often refers to devices that are fixed in some point of interest, for example, while the term tag comes essentially from the auto identification industry and typically refers to devices that are attached to assets or to people. And so sometimes a beacon can be stupid, but sometimes can be smart. So clearly a stupid beacon is a transmitter that always makes the same functionality. So it periodically advertises its identifier, nothing more. So, but if we add some logic inside, So because this device has its own microcontroller inside, so we can turn a stupid beacon into a smart beacon. So a device that can implement some functionality. For example, I can have some sensor, like an accelerometer or a temperature sensor or a contact sensor, and I can implement some functionality depending on the parameters that I'm going to measure. So the term beacons will emerge in the mobile market in 2013, 2014 with the launch of iBeacon format from Apple and with the introduction of Bluetooth Low Energy specification into the Bluetooth 4 standard, with the Bluetooth Low Energy included in all smartphones and mobile devices. So Bluetooth Low Energy is quite different from the standard Bluetooth, the classic Bluetooth, and it comes from a technology that was originally developed by Nokia in 2006. It was called Webri, and essentially the difference is that Bluetooth Low Energy is mainly focused to send short messages, while the classic Bluetooth is developed to send large amount of data, like videos or files or something like this. So the real beginning of beacon technologies comes with the launch of iBeacon specification from Apple in 2013. And iBeacon is essentially a specification for an advertising package, and which includes a unique identifier of the device, which is encoded with a particular format. And the specification also includes some other details. And this is essentially the format of the advertising package for the iBeacon. This is something that maybe all of you are aware of. And in particular, one information which is included is about the received signal strength, which is calibrated at 1 meter from the transmitter. And typically this information is used to estimate the proximity. So let's say not the distance, so the range from the transmitter and the accuracy. And this is very important because there is some confusion on the market, because many people think that this information is a measure of distance, but actually is not a measure of distance. It's an estimation of proximity, and this is why Apple define 3 ranges, which is immediate, near, and far, and they are quite large in the range. So, and if we go in more detail about the accuracy definition, so we see that the accuracy is a sort of probability region where we can around the beacon. So it's not a distance; it's something related to a probability to be at a certain distance from the transmitter. And why this? So in order to understand the motivation, you can refer to this simple graph. So the red line is a very simple 2-ray model for propagation in for radio signal propagation at 2.4 gigahertz. And as you can see, the curve is quite noisy, so you see many minimum and maximum. So it's very difficult to relate. So it's it's impossible to relate a received signal strength indicator to distance. So what we can do is a probabilistic model that may depend on the environment, where we can estimate the range, but where we cannot estimate the actual distance. And after, during the presentation, we will see that we can improve performance of localization systems with Bluetooth, with some novel solutions which are based on the angle of arrival and the angle of departure methodology. So after the iBeacon specification in 2015 and later was updated in 2016, Google launched its own specification, which was called Eddystone, which a bit more complex because it defines not one but 5 packet formats, including an encrypted unique identifier packet. So it's the application is similar. So we're still in the mobile market, but with a different definition of the packet format. So if we go to see the internal format of the Eddystone advertising packet, we see that the data is similar. So we have essentially a unique identifier, and we have a calibrated RSSI at 0 meter, not 1 meter, but the format is different. But essentially, the target application are the same for both iBeacon and Eddystone. So up to now, we are still in Bluetooth 4 specification. Later on, with Bluetooth 5, some interesting new features have been introduced that are very appealing, especially for industrial applications. And so now I'm referring essentially regarding to what are interesting to the angle of arrival and angle of departure methodology to improve the accuracy of positioning, and to solution for mesh network. So with Bluetooth 5, the Bluetooth range specification creates a portfolio of solutions for creating more complex networks and solutions. So what is angle of arrival and angle of departure? So I will not enter into details, just an image to show what is intended with this terminology. So angle of arrival essentially is a solution where we have a transmitter, which is this device, it can be a tag, and we have a receiver, which is more complex than a standard BLE receiver, because it has an array of antennas that are able to compute the angle of arrival of the signal. So having this information and with some triangulation algorithms, we can increase the accuracy in the positioning of the transmitter. So the angle of departure is essentially similar, but is a specular approach. So in this case, the transmitter is this complex array, and the receiver is able to compute the angle of departure based on the information that are included in the packet. So essentially, in both cases, we have an information about the angle, but in one case, it's computed by the receiver, which is a fixed installation. In the other case, it's computed by the mobile device. With Bluetooth 5.1, it was also introduced support for mesh network. So I will not go into detail on this because the definition specification about mesh network it's quite complex. As you can see, there are a lot of definition about the roles that the devices can have inside a mesh network. So depending if you have a battery powered node or if you have cable powered node. But what we are interested in is the fact that with a mesh network, we can have the information that through multi-ops jump from a node to another end node inside the mesh network. So the Bluetooth Low Energy is no more limited to a star topology, but now we have a more complex network topology. So, and this just to provide a very quick introduction about Bluetooth Low Energy, about beacons, and about some novel solutions. So now I will jump to the technology portfolio of BlueUp, and I will show you some of our solutions in order to understand how the BLE technology and the beacons and tags are used in the industrial market. So BlueUp has a portfolio where we can support some of the measured market standards. So from iBeacon to Eddystone, with full support of the specification. We have support for Coupa technology, which is proprietary technologies for angle of arrival and angle of departure RTLS platform. We have support for wirepass mesh network, which is again a mesh network technology, which is different from the Bluetooth standard, but it's more energy efficient. And we also have our own proprietary solution for contact tracing and social distancing. So just a quick overview about our product portfolio. So these are our beacons based on Bluetooth 4. So these are essentially used for fixed installations, both battery powered or line powered. And the last generation of products that are based on a chipset which have the support for Bluetooth 5. We have both wearable beacon, or more correctly, maybe more wearable tags, like a wristband, like a card, or like a key fob, or industrial tags, like the Forte Plus or the BlueBeacon Brick, which is has been launched from just a few days. And this is our portfolio for gateways. Gateways essentially is a device which is typically powered, not from power line, and it is able to communicate on one side with beacons, and the other side can communicate with the internet or the cloud. For example, you can use as antennas for location system or for configuring tags and so on. And so this is the solutions that we have regarding the firmware for the devices. So we have our standard firmware where we can support the typical packets for mobile application like iBeacon, Eddystone, and we have our own proprietary format, which has been called Safety. We have firmware which is based on Coupa technology. So Coupa compatible means that they have been certified by Coupa to be compatible with their infrastructure, and the WirePass mesh firmware that support either non-router devices like mobile tags or router devices like anchor tag. So let's jump on a possible application of BLE. One possible application is using these technologies for implementing real-time locating system or indoor positioning system. So if we have a network of anchors, so we can take the information of all these anchors in order to estimate with more or less accuracy the position of a Bluetooth tag inside an area. So this allows to make a sort of indoor GPS for tags. And we have three different solutions that are based on three different technologies. So the first one is based on the Coupa angle of arrival technology. It's been named AccuRTLS. The second one is based on our solution for using the RSSI. And then we have a solution based on the WirePass mesh architecture. So let's see the difference. Essentially, that with the Coupa solution, you have fixed antennas that are powered, that are able to compute the angle of arrival of the signal from each tag, and then you can compute the position using the information of the angles. So this is very very accurate solution. So with Zone RTLS, the infrastructure is similar, but here we have simpler antennas that are not able to compute the angle, but they are able to compute the receive power. So as we have seen before, the receive power can be quite noisy. So this solution is not able to provide a precise position, but can provide information about the zone where your tag is located. And finally, the MeshIPS solution does not use any cable device. All these devices are battery powered, so you have a mesh network of completely battery powered devices, and where you can able to locate your tag that moves inside your mesh network. So in this case, here you have less accuracy, but you have no cost about infrastructure. And so just to have a comparison with the Coupa solution, so you have a very high-end performance in terms of accuracy, in terms of real time. With the Zone RTLS, you have a compromise between accuracy and real time and cost. While with the WirePass, you have less accuracy. The refresh interval is longer, but you have a very cheap solution. So clearly, with a compromise between accuracy, real time, and cost, you can identify your optimal solution for implementing positioning in indoor positioning system. And finally, just a quick overview on our solution for contact tracing. So the last epidemic of COVID-19 pushed us to design a new solution for enabling social distancing and contact tracing. So essentially using a tag with some more complex software inside. You can either transmit and receive the signal from nearby devices. So you can implement a solution that allows to monitor the proximity between two or more operators, and so you can have a control of crowd or distancing inside your offices, inside your plants. And essentially, the functionality is quite simple. So each operator has its own tracer device, and when two operators come nearby each other, the device starts signaling this event with the LID or a buzzer or a vibration, and this event is saved into the internal memory. So you have both the functionality for proximity alert and also for contact tracing. And you can download these contact events using a gateway, and then you can have a backward identification of the contacts of each operator in case you have some infection in your offices or in your industry. But we can also integrate this solution with a zone location platform. So you have either the contact tracing and social distancing solution, but at the same time, you can have a real-time zone location, and you can also have a real-time information about crowds inside the plant. So this allows adding some antennas to also have a real-time monitoring of the situation that you can have. And finally, so just a very, very quick overview of all the possible applications that you can implement using the BLE beacon technology. So maybe the first one that was launched with the iBeacon was proximity marketing. So if you go inside some shop mall, you can get some information about products or discounts depending on the position where you are inside the shops. For example, we can enable proximity payments. For example, using a beacon with typically with an encrypted packet, so we can have an authenticated information about the position of the user, so we can enable payments. For example, this is a solution which has been applied for oil gas, for oil pumps. The same, you can have information in museums about what you have inside the museums or fairs or something like this. Other interesting applications about smart ticketing. So you can use beacons to locate travelers inside a train, for example, or inside a bus. So you can enable the ticketing through mobile phone without using standard paper ticket. Another solution is using beacons for indoor navigation. So instead of using just one beacon, you will have a network or more dense beacons that are installed, for example, inside an airport or inside a railway station, and the travelers can navigate and find their path inside the airport using a mobile app that uses the information from the beacons to locate the mobile smartphone. So other solutions are, for example, for the food sector, for self-service, in order to, for example, locate the, the customers inside the restaurant. And this is another solution that being implemented for using the BLE technology. Or, for example, for industrial application, you can use beacons in your warehouse. For example, you can apply tags to pallets or to people, and you are able to locate and track uh, personnel or assets in your warehouse. Similar application have been used, for example, in hospitals in order to track high-value assets inside hospitals or to locate uh, personnel inside hospitals. So warehouse is just an example, but you can use such kind of solution for offices, hospitals, and plants, and so on. And yes, I think that, okay, this is the last slide of the presentation. So I hope to, yeah, I am in line with the time schedule.
Thank you very much, Alessio, for this interesting presentation where you have shared with us what is BlueUp doing in the beacon technology industry, and also how is RTLS solutions are becoming part of the everyday operations in different industries. If you have any questions, please write them in the session's chat box so Alessio can answer them for us. Let's wait for a couple of minutes to see if somebody has questions. Alessio? I'm just receiving one question here, Alessio. How can we get BlueUp beacons and solutions in the United States? That's a very good question.
Yeah, so we have our valuable partner, which is WID, which is our one of our main partners worldwide and our reference partner for the US market. So all the customers from US can refer to WID for information and for purchases of our products. So I see one question. So I see that Douglas Dominic is asking the difference between iBeacon and Eddystone, Apple against Google. So essentially, iBeacon and Eddystone are just two different specifications for advertising packets. So one has been defined by Apple and the other one has been defined by Google. This does not mean that you have to use iBeacon with iOS and Eddystone with Android. You can use iBeacon with both Apple and Google devices, or vice versa. So there is some difference about the libraries and the internal support, because the iBeacon has a native support in iOS devices that allows you to have a more robust implementation, while Eddystone you have to base your SDK on the BLE libraries, while on Android devices you can either use iBeacon or Eddystone. There is not so much difference. So the main difference is that Eddystone, maybe it's a bit more complete solution because it includes different packet formats, and so you are able to advertise more complex information about the device. And then I see another question about the CUPA and wireless mesh. So yes, so Coupa and Wirepass are two different companies that have their own technology, and BlueUp has some of its products, some of our tags support this kind of technology, and but this is a third party technology where we are going to use some proprietary libraries to implement our solution on our hardware. So now I see another question about
That's a question about the safe extractors when they are used in heavily industrial environments where people wear eardrum protections and heavy clothing. Yeah.
In general, we suggest, so as we have seen, the BLE is not able to provide a precise measure of the distance. So it's a proximity estimation. So in fact, we suggest to wear the SafeX device in a proper way, for example, with a lanyard or with a clip on your chest, because the signal path is not obscured by obstacles. So in general, we suggest not to wear these devices under the clothes, because maybe you can have reflections. So don't use them in the pockets or somewhere. The better option is to wear in such a way that the device is visible from other users.
Okay. And the last one there, Alessio, is thank you, Alessio. Very interesting future of beacons and RFID against possible new technologies. What do you think about it? The future of the beacon technology.
Yeah, I think that each technology has its own primary field of application. So there are a lot of technologies out there. So from passive RFID to active RFID to BLE to ultra wideband to LoRa, and maybe in the future will emerge other technologies. So in general, there is no technology for everything. So each technology has its own feature and its own limitations. So I think that with respect to passive RFID, BLE allows for implementing more complex infrastructure and smart infrastructure, but clearly at present, BLE cannot compete with passive RFID, where you have millions of tags because of the cost of the single tag. And for example, BLE can compete with ultra wideband for location, but also in this case, ultra wideband is more adapted for when you have a reduced number of tags because of the cost of the tag. So in general, there is no solution, no technology for everything.
Thank you very much, Alessio. That's it for this session. We would like to thank you very much for your time and all the very rich material that you presented this day with us. In name of WeID, we will be very happy to help you if you want to contact us in our virtual booth. We are around here to help you with the beacon needs for different projects that you have. Thank you very much,
Yeah, yeah.
everybody.
Thank you, Luis, for the invitation. I see that someone is asking for a copy of the presentation. I think that Luis, you can share it, maybe.
Sure, we can share it in the virtual booth. We will share the presentation, and also we have recorded all the presentations, so we can share it in our social media channels.
Okay, excellent.
Thank you very much.
Thank you very much, Luis, for this event. It was very nice for us to be here and to present our technology. Thank you very much again.
Thank you,
Alessio.
Thank you, Alessio.
Thank you. Bye-bye.
Bye-bye.
Much.